So we recently carried out a project where our goal was to assess the carbon footprint of milk produced on 4 different smaller farms around the country. And to complete that objective, we used models that have been developed by other researchers that account for all the different facets of how a farm works that can influence the carbon, the methane, and other gases that are emitted by that farm in comparison to the amount of edible milk that's produced on that farm. So a model is a mathematical description of something that happens in nature. The models that we're using are built into computer software that allows you to plug in all the different components of a particular farming operation. So what kinds of diets do you feed your animals? What kind of housing do you have? Importantly, what is your manure management program, and how are you growing crops? And all these things go into the software then that uses relationships in the background then to predict how much greenhouse gases are produced in relation to the amount of milk produced on that farm. So the reason we have to rely on these models to do most farms is that it's just incredibly difficult on a farm to actually measure gases coming onto and leaving a farm. So we're standing here in the middle of a farm, there's wind blowing past, we have animals spread out over hundreds of yards across the wind. To be able to actually measure what gases are coming off this barn, much less the fields, would be incredibly difficult. And so past researchers have done that on certain farms, have picked up factors that have a big impact on the measured gas fluxes, and then they build these equations, this model, and put it into software so that we can try to apply that knowledge on many other farms without spending $100,000 on every farm to try to measure those changes. So there's a classic line that people in modeling use all the time, is that all models are wrong, some are useful. So there's no mathematical equation that's going to perfectly describe nature, right? No matter how complicated it is, and that's the reality. So we do have to acknowledge that the models we're using are imperfect, but they're directionally correct. They've been peer-reviewed, they've been tested and validated, and they're sort of an accumulation of the best knowledge we have as of today. We always assume that moving forward, we're going to learn more things. We're going to learn ways in which the model today is wrong, and we just accept that. But the value of doing it nonetheless is, again, it points us directionally which way should we be turning to try to make these numbers better. With the growing importance of environmental sustainability to consumers and the increasing, I'd say, integration across the food chain in terms of environmental claims on products, I would really encourage dairy producers to be proactive and, for now, at a minimum, start trying to keep super good records on when manure is applied, what fertilizers on every field. But of course, records on the herd as well are very important. So understanding total number of animals on the farm, how many are productive, average productivity, all those standard things that we want to use for good dairy herd management are really big players in this model as well. For the dairy industry as a whole, using these sorts of models and trying to understand what the true footprint is on different farms, I think is valuable, not only because consumers demand it and we need to be responsive to the end users, but also because it points to what's the range of outcomes right now and lets us hone in on those farms that are exceptional in terms of having a minimal impact. If we can identify those farms that already have a low carbon footprint per gallon of milk, that lets us ask about what are the practices on these farms that appear to be commercially viable that they're using, that then we can talk about with other farms and have them consider adopting.